Lesson 4-2, relations and functions. Let's start off with some vocabulary here for your know-it notes on page 52. Okay. A relation. A relation is a set of ordered pairs, like the ones that you graph, in parentheses, 3, 1, 5, -2. That's all it is. It's just a set of ordered pairs. We can show those in several ways. You can jot these down. They give you lots of room on the 2 lines there. So write these 4 things down. Right? You can show it as a graph. You can list them in set notation. That means like this, and we'll talk about that in a minute. Okay. That would be a list of ordered pairs in set notation, the wiggly brackets, the braces. You can make a table of the ordered pairs, or you can make a mapping diagram. And I think of those, really the only thing you haven't ever seen before might be the mapping diagram. Below the box down there at the bottom, go ahead and make a mapping diagram, one of the 2 on the next slide, so that you can see how they work. And actually, I think the one that I would write down would be this one. A mapping diagram, you list each value once, and then you connect the x and y values with arrows. Okay. Usually you list them in numeric order, right, just to make life easy for everybody. Right, so here's my ordered pairs, 2, 3, 4, 7, 6, 8. So I list the x values, I list the y values, and then I connect them with arrows. If there's any repeated values, you don't write them more than once. So if you look down here at the second one, we have these ordered pairs, and you can see that 0 shows up more than once. So we only want to write it once. Okay, these are in increasing order, -4, -1, 0. And these are in decreasing order for some reason. I probably would have been more likely to do it the other way, but it's not critical. Okay. And then we connect the x and the y with arrows. Okay, so that you can see at 1, 0 and 5, 0, they both connect to the same y. I know this doesn't seem like a really useful thing to be able to do. It's just another way to be able to visually show the relation. I particularly would prefer a table, but this is something that that you could do instead of a table. Okay. Here's the other ways. Right? It's given to you as a list. So we had 4 options: list, and then we have a table where you just list the x values and the y values matched up. If there's repeated ones, you would list all the repeats. A graph. This one all has only positive values, so we only have the first quadrant of the graph. 1, 3, over 1 up 3, over 2 up 4, over 3 up 5, and then our mapping diagram. And once again, if it's most proper, it should really have arrows. And you don't need to write that down because you already know what a table is, you know what a graph looks like, and you just drew a mapping diagram on from the previous slide. More vocabulary. Domain. Okay. The domain is the set of x values of the ordered pairs, and we generally list them in as a set in braces. The range is the set of y values of the ordered pairs. This is really something you just have to memorize, which is the domain and which is the range. For me, the easiest way to always remember it is that domain comes before range in the alphabet, and x comes before y in the alphabet. So D comes before R, right, X comes before Y. Right, they're in alphabetical order, both of them. And then we write them as sets in braces for discrete data. And then the tricky part, this is probably the hardest part of this whole lesson, is to write them as inequalities when we have continuous data. And we'll do an example of that in just a moment. So you're going to give the domain and the range of the relation. Jot it down there below the box. I'm just going to do this kind of problem once. And The only thing you have to know really to do this accurately, besides remembering that domain will be the x values and range will be the y values, is that you don't write any repeat numbers. So anything that repeats, you just write it once. So go ahead and jot those down. You can pause the video for a moment if you need more time. The answers would be, in braces, the x values are 1, 4, and 8, and the y values for the range are 1 and 4. They don't have to be in numeric order, but you'll generally see them written in numeric order. That's really all it is. You list the numbers from the x's and you list the numbers from the y's. It would be the same thing if it was given to you in list form. Okay. I don't want you to sketch this one. I mean, you can if you want to, but you don't have to sketch the graph. But what I really want you to pay attention to is how this works. The domain are the x values. So we're looking at where does this function go on the x-axis. So it goes from 1 out to 5. And it can be any value between 1 and 5, right? Even like 2.374333. So we're going to write it as an inequality. It goes from 1, and it's a solid dot, so less than or equal to 1 with an x in the middle, all the way up to 5. Okay. 1 is less than or equal to x, which is less than or equal to 5. The domain is any value in between 1 and 5, including the endpoints. Now for the y value, for the range, right, we're looking at where it is on the y-axis. Okay, so now it's here. So the pink was the domain, the y is and the blue is the range. So it goes from 3, right, up to 4 in order numerically. Y has to be between 3 and 4. Okay. And you can still put them in set notation. I'm not sure, I can't remember now if the book does or not, and I forgot to look it up, so I'll have to tell you in class. And I promise we will go over more of those continuous range and domain problems in class. I don't want to spend a bunch of time in the video doing it, because we're now going to talk about functions. Last year you talked about functions too, so this should be a review. There is a spot for a definition for function on page 52, so go ahead and write that in. A function is a relation where there is exactly one and only one output for each input value. There's exactly one and only one output value for each input value. We're going to add to that definition in just a moment. So don't take your pencil too far away from there. All the pictures here are examples of functions, and you can see the abbreviation there, fxn, which we usually use when we're writing the word function, so we don't have to write the whole thing out. I want you to add to your definition, right? In other words, every y value must have a different x value. Here's what I really want you to add. No x values can be repeated. Okay? It is okay for y values to repeat. So in a function, no x values can be repeated. The y values can repeat, but not the x values. That's the easiest way to check to see if something's a function when you're given a list of the ordered pairs. I'll show you another really easy way to check to see if something's a function when you're given a picture of it. So just working with me, take a look at this first one here, where my pen is, and think to yourself, is this a function or is it not a function? Really, the only thing you need to check for is, are there repeated x values? Hopefully, what you said to yourself is, no, there's no repeated x values, so that means yes, this is a function. Okay. On the second one, right, I'm looking at my y's, they're fine, but when I look at my x's, I see -1 twice, and I see -2 twice. Repeated x values mean not a function. Okay. Really though, my favorite definition for functions has to do with what's called the vertical line test. And if you look over at page 53, they actually talk about this in the next section of the book, but it makes more sense to talk about it now. So the way that the vertical line test or the pencil test works is that your pencil can only touch the graph at one place when it drags across. So if it crosses the line of that's on the graph, whatever the graph looks like, more than once, it's not a function. Let's show you how it works on the next page. Okay. So take a guess. If you want to sketch a couple of these at the bottom of page 52 if you have room, or even over there on page 53, you can do it over there. So you're thinking to yourself, let's number these off. This is number 1. Is it a function? Is the yellow pencil, when I drag it across, is it going to cross the red line more than once? Should have made your decision. Ready to see if you're right? Okay. Dun, dun. Oh no, the eraser gets left behind, right? Absolutely. It crosses more than once in a whole bunch of places. That means this is not a function. Okay. How about the next one? This one right here where my arrow is. This is going to be the next one, number 2. And when we drag our pencil across, make your guess. Touches once, touches once, touches once. My pencil's really fat, so maybe you're thinking it does touch more than once. It's just because my pencil's fat. Okay? So it's only crossing the red line once, so it is a function. Notice you can do this yourself when you have a function on your paper, on a test. You can just drag your pencil right across it. And the third one, down here at the bottom, take your guess. Is it a function? Is it not a function? Dun, 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 dun. Crossing once, crossing once, crossing once. And it's fine, right? So it is also a function. And I'm actually going to save that for in class. So you're done. Easy, fun, fabulous. And we'll talk about functions more when you come back to school.